Hi everyone, my name's Arik Humuradoris and today we're going to look at the concept of algorithms and the sense they make in the world of programming. Algorithm problem solving refers to the process of designing a systematic set of steps to solve a specific computational problem. These algorithms they evolve breaking down a problem into smaller manageable steps, defining the sequence of operations needed to arrive at a solution. We are going to look at the characteristics of effective business algorithm, and we're going to begin with clarity. Algorithms should be clear and easily understandable by stakeholders involved. Efficiency. Emphasis on designing algorithms with optimal time and space complexity to ensure efficient execution. And our third point is accuracy. These algorithms must produce accurate results consistently across different scenarios. By this, I mean these algorithms, they should produce the correct output for all valid inputs. We have a few application areas in business where these algorithms are put or applied. And our number one is inventory management, implementing algorithms for inventory optimization, demand forecasting, and stock replenishment. Supply chain management, utilizing algorithms to optimize logistics, routing, and distribution network. Then we have the financial analysis, applying algorithms for risk assessment, portfolio optimization, and fraud detection in financial transactions. The financial analysis, by this I mean, for example, an ATM card withdrawal. By this, I'm going to explain, for example, if a person wants to withdraw the money from the ATM card, the algorithm in this, it is using the PIN. The algorithm is the PIN, the passwords that we put even in our phones, for example, for the privacy, not that have privacy. This is where the algorithm comes in the financial analysis. We have the customer relationship management, leveraging algorithms for customer segmentation and personalized marketing strategies. Algorithms are used in marketing, which help customer relationship between the seller and the customer. We are going to look at the advantages of these algorithms, whereby our number one advantage is it promotes efficiency. These algorithms, they promote efficiency, which helps to minimize resources and save time. And our next advantage, it is they enable scalability. Then it facilitates code maintenance and reuse. On the efficiency part, these algorithms are designed to solve the problem in the most time and resource efficient. Then we have accuracy. These algorithms, they produce correct results which are used to solve problems. We are going to look at the disadvantages of these algorithms, and we're going to start by looking at the difficulty in designing optimal algorithms. The need for computational resources. There is also complexity in designing and analyzing algorithms. Sometimes it's very hard for the user to design an algorithm which is used to solve the problems. Now, next, our last disadvantage is algorithmic biases and unintended consequences. So these are the few advantages and disadvantages that we have in this algorithm problem solving. So we are going to look at the steps in algorithm problem solving, whereby we begin with understanding the problem. Clearly define the problem statement and identify the input, output, and the constraints. In these algorithms, we use these algorithms to first define the problem. And then after defining the problem, we plan the solution. We plan the solution by determining the algorithmic approach, select appropriate data structures and control structures. Then we implement the algorithm. Write the base code on the algorithm designed. And another step that we follow in algorithm problem solving, it is test and debugging. Verify the correctness and efficiency of the algorithm through testing and debugging. We test if this algorithm will work or will solve the problem we have. And then our last step is analyzing and optimizing. We evaluate the algorithm's performance and optimize it if necessary. We analyzing this by putting this algorithm at work in order to see, is it working? These are the few steps that we follow in algorithm problem solving. Now I'm going to give you an example of problem solving using algorithms. I'm going to give you an example of a supermarket that wants to optimize its inventory management to minimize storage costs while ensuring sufficient stock levels to meet customers' demand. So this supermarket wants to optimize its inventory management to minimize storage costs while ensuring sufficient stock levels to meet demand. We have the input, current inventory levels for each product. To input the demand forecast for each product, or input the storage capacity of the warehouse. Because now, as you've seen, our supermarket, the problem it has that it wants to optimize its inventory management to minimize storage costs while ensuring sufficient stock levels to meet customer demand. And then we're going to output updated inventory levels for each product, purchase orders for replenishing stock if necessary. And then initialize variables, set storage capacity as the maximum storage capacity of the warehouse. We initialize these inventory levels for each product. We check the inventory levels, compare the current inventory levels with the demand forecast for each product, and then identify the products with low inventory levels below a certain threshold. And our another step is optimizing inventory. Calculate the space available in the warehouse after considering existing inventory levels. Then determine which products need replenishment to meet and demand without exceeding storage capacity. Prioritize replenishment based on factors such as product demand, profitability, and shelf life. We generate the purchase orders. Create purchase orders for the identified products to replenish inventory. Consider factors such as supply, lead time, order quantity, discounts, and shipping costs. Update inventory levels. Receive and process incoming inventory based on purchase orders. Adjust inventory levels accordingly. Update inventory records and stock tracking system. Then we have the validation. The validation, we are having the testing. We test the algorithm with historical data to ensure accurate inventory management and cost optimization. We monitor the key performance indicators such as inventory turnover ratio, stock hours, and storage costs. In the validation is where we test the algorithm that we have applied. And then the optimization, as our last point, it is the continuously refining the algorithm based on the real-time data, market trends, and customer feedback. Implement advanced forecasting techniques, demand sensing technologies, and inventory optimization model to further improve efficiency and accuracy. So I'm going to give you a simple explanation as to why these algorithms they make sense in the world of programming today, and the reasons as to why these algorithms make sense in the world of programming today. We have reusability as our number one point. Reusability: once you have developed an algorithm to solve a specific type of problem, like sorting a list of names, you can use the same algorithm in different programs whenever you need to perform the same task. It is like having a master recipe that you can use over and over again. And then our second point is automation. These algorithms, they're like a backbone of automation. Like, they allow us to instruct computers to perform repetitive tasks automatically, freeing up human time and effort for more creative and complex work. For example, as you see in different homes, people have washing machines. These washing machines follow a set of steps like filling water, adding detergent, washing, greasing, and spinning without needing human intervention. The repetitive tasks that this washing machine does, it is part of the algorithm that is put in the washing machine. It follows those steps every day. Like, it can do that work without any human intervention. Okay, what I'm trying to mean, like, it does the repetitive task over and over again. And then we have the problem solving. These algorithms, they provide a structured way to approach and solve problems. By thinking in terms of inputs, processes, and outputs, we can design logical steps to arrive at the desired solution. And our last one is efficiency. By carefully designing the algorithm, we can find the most efficient way to solve a problem. A well thought out algorithm can save time and resources by minimizing the number of steps these computers need to take. So, as I am concluding, as I have explained all the concepts, the advantages and disadvantages of all algorithms, and the step-by-step procedures of solving real-world problems, whereby I use scenario of a supermarket, I'm very sure a supermarket, and then I also gave you an example of the washing machine. I'm very sure that now my friend Adriana deeply understands the concept of algorithm and why they make sense in the world of programming. Thank you for your time. Thank you for listening. Have a good day. I remain Kilmura Doris. Thank you.